in AI, and especially how we use it to make the service desk smarter. For the ones of you that don't know what is a service desk or it's never used, I will explain it in the beginning of this presentation. So starting from the introduction of, in general, what is the IT service management and what is service desk, and how AI will change this domain and how it can be applied to make it smoother, smarter, and easier for the usage and for the efficiency of the company. Then I will introduce some models that we tested that are used in the ITSM, and which data we use for the experimentation is a publicly available dataset, so you will try it out and see how it works and possibly do something better. And then we compare the model performance and their speed and model size and draw some simple conclusions. So starting from the ITSM, we have to go back to the 80s when the IT started becoming more and more popular, and there was the need for the developers and IT employees to get some support from team that were specializing in giving this support, and the help desk was created to provide both the users and the employees of the companies information and support about services and products that were available. And as I mentioned, this was starting with the IT. And then it evolved to other areas of the company, so they started creating help desk for finance, for legal support, for recruitment, and was adding more and more systems. So then it raised other problems. For the users it was quite difficult. So it became clear that there was the need for a single portal where all the users could go, raise their request, ask for support, report incidents, and that's how the service desk was created. Service desk, that is a part of what I mentioned before, the IT service management, which is a group of services that follow all the life cycle of the IT products, from the early design to the maintenance for the customers. So you can find service desk in your company, and you use it when you need something from your company. You can find it in products that you use from other providers. And just to know, how many of you use service desk regularly? No one? Good. I thought it was more spread. It's efficient, it's a good system because it solves a lot of problems, but it raises problems as well. So this is more intuitive representation of what they are. Actually, inside the service desk, there are several help desks covering different areas. And one of the main issues that are raised when there are more and more of these services is that you have to manually decide to which help desk go and assign your ticket that then gets assigned to the right resolution group. And this is one of the main applications AI can help with. It can help finding from a knowledge base suggestions on how to solve your problem, even without having to raise a ticket, because problems are quite common in the end, mostly in large organizations. And this is what we're going to focus today. AI can be applied also for other tasks, like some automation, for example, in terms of password reset or opening some IP addresses in the firewall and this kind of task, granted access to some users to a certain repository, simple things that are time consuming because they happen really often and then can be automatized. As I mentioned, today we're gonna focus mostly on the ticket classification because it's probably the most simple task, and at the same time is the most time consuming. There are lots of tickets that get misclassified by the users because maybe you have hundreds of projects that are available and you don't know which one to choose, mostly in the beginning when you enter a new organization. And tickets float around IT support teams for days or weeks before getting just to the right person, then maybe it takes 10 minutes to solve it, but you wait 1 week. So we want to make this smoother for the users and to help the business as well by reducing cost and time. This is just an example of what a ticket looks like in our service desk. As you can see, it's a general access request because I just made an example of when I needed access to a repository on GitLab, but I had to choose the ticket type that was an access request. In this case, it was pretty straightforward, but I can guarantee you that there are a lot that look really similar. You don't know which one to choose, spend time, get frustrated. That is not good. So ideally, you will have a Google-ish interface where you just type your issue and then the system will take care of the rest. Currently, there are services available. I mentioned just two. One mostly is the same approach that we follow of using a service that first try to look in the knowledge base if it has an answer, and then after it creates the ticket, automatically classifying it. Is the top left. But in this case, the service offered has the limitation that the model is standard, so it's not customized to fit your organizational structure, and this raises problems because different companies have different support structure. They do different things, so they require customized models. BMC offers the possibility to customize it on your data, but it's limited in terms of model working in the backend. They use IBM Watson, but depending on your organization, on how much historical data you have, what kind of tickets you mostly raise, you may prefer other services. So what we believe is the optimal approach is to look at your data, evaluate different models, decide which one suits best for your needs, and then structure it with a microservices architecture, deploy it either on cloud or install it locally on your servers, depending on security needs and other choices, decisions that I will go through later. And then just communicate with your service desk through webhooks that are triggering your model, which then uses the REST API of the service desk to update the ticket and assign it to the right resolution group. This was just a quick introduction for the ones that didn't know the domain. But what I will say from now on later, it's general concepts that are applicable to any domain. I just use these use cases as an example because it's quite complex, because the language is natural but not supernatural, I would say, because we write ticket in a different way than we speak, or usually they're not extremely formal. They have a technical content, so it's a quite complex domain. But the principles that I will mention are general and can be applied to any project. So we evaluate 6 models, 3 that we developed and trained locally, and 3 offered by cloud services providers, the tech giants. And starting from the GBM, I will just introduce them quickly. If you have questions about the models, you can either ask now or after the presentation.
I have a question about how much data do you have? Like,
I will introduce the datasets after, yeah. Around 40,000 tickets.
40,000?
Yeah, but I will show them how they look like after. So the GBM is a gradient boosting framework released by Microsoft some years ago that gained popularity because it's the lightest and fastest tree-based learning algorithm, which has a very specific feature, that is that the tree is built leaf-wise instead of level-wise, so it grows vertically and then it moves instead of building level by level. And this speeds up both training and inference and allows easier parallelization and GPU training. As all the learning models, it needs encoding of the inputs, and we just use simple TF-IDF, which gives importance to words that are appearing in the specific document and are rare in all the others. So basically the input representation is just a big matrix that is representing the importance of each word and per each document, basically. This is what means the leafwise growth. So we start from the left and we build the tree until we reach a certain depth that is one of the parameters. There's more than 100 parameters, but thankfully you don't have to try them all. It's just a few ones that are relevant, and there are quite good documentation about it, to which ones to play with depending on your data size. I will not go in the details of the parameter. If you want, we can speak later about it, but it would take too long. The second model is fastText. That is Facebook model that they released 3 years ago, and is being the first big change after Word2Vec. It's been the first model that solved the problem of out of vocabulary words. And there are pre-trained models available. Basically, it's an embedder, so it gets a word and outputs an embedding. You can either use pre-trained models or train it from scratch. In this case, we did train it from scratch because domain is quite specific and technical, so it was likely to assume that many words were not been seen in the large pre-trained model, and even if it's able to handle them, the representation is likely to be not meaningful. So how it solves the problem of out of vocabulary words is just splits the words in character n-grams, in this case 3 grams, so that it just takes the charter to build the embeddings of the new words that it has never seen before. And then it predicts each word based on the surrounding context to build embeddings. So basically it sets a goal of predicting each word. So for example, the word fine, given the context on its left and right. And by predicting each of these words, it adjusts all the parameters, all the embeddings to learn how to represent each word in the embedding space. So the same word gets represented with completely different embedding depending on the corpora that you train on. Anton?
Do you mean by word the n-grams or word? When you say words that they have embedding, do you mean that each n-gram has an embedding?
Each word has an embedding that is learned by splitting it in n-grams, but then they're combined. And each sentence is embedded by making the average of each word of the sentence. That seems very simple and non-advanced embedding way, but it works quite well. On top of it, they just use logistic regression as a classifier, and we use that, but you could use any classifier because once you have the embedding, you can decide what to use. The third model that we developed is BERT. Everyone has most likely heard about. Transfer learning should work quite well also in this domain. I don't know if I should go through the details, but it applies the concept of pre-training in a self-supervised way on a large data set and then fine-tune the model depending on your task, on your data. It uses existing embeddings from, for example, Word2Vec, and it concatenates it with the sentence embedding and the positional embedding. I just mentioned why they use the positional as embedding, because from transformers that came out in 2017, famous Google paper, they get rid of the recurrency and they feed all the network with all the words of the sentence at the same time. So we need somehow to say with each word where it stays in the sentence, which position it takes. BERT is nothing but transforming the embedding that it gets in to represent it in a better way. And then, as before, we just use any classifier on top of it. Why it became so popular? First, because it's state of the art on most of the NLP tasks of several percentage points. And also because while the pre-training is extremely demanding, days and days on, or months maybe on a CPU, and days on their powerful DPU clouds, the fine-tuning is relatively light, and you can decide how many layers to fine-tune. You could just train your classifier. Usually what you do is to just fine-tune the last 1 or 2 layers, because the bottom layers learn how to represent language in general, the grammar, and how words are related to each other, while the top layer are the ones that change most, depending on the use case that you face. So just any classifier on top. I will use just a feed-forward network with one hidden layer. Other big trend of the last year and this year is the rise of the AutoML. That is this approach that tech giants use on offering machine learning models like text classifiers in this case, and they try to find the best performing model based on your data. I assume trying out a lot of configurations due to their basically unlimited computational power. We will not compare with Azure because they don't have a pure text classifier. They have a very nice graphical interface where you can drag and connect different components. So you could have, for example, taken the TF-IDF, connected to an LGBM, and then see the results, but it was not interesting. I mentioned the region because not all of them are available in Europe yet, and these may have some limitations due to the GDPR. They have limitations in terms of training set size. Watson is quite limited, actually. I think that 20,000 sentences or documents is too little in general. Amazon is basically unlimited. More than 5 gigabytes of text is not something that you fine-tune a model on, usually. I mentioned the price. Might seem expensive if you think as a person, but as a company, I don't think the price should be a big deal. Even if you raise hundreds of thousands of tickets per month, that should mean that you have quite high revenue. So, hopefully. So that's just to mention for completeness, but I don't think it's a problem. As you asked before, of course, data is important. Endava and Microsoft have released Endava support tickets, and I decided to use these ones so that everyone can then have a look at them and try it out. It's extremely unbalanced. That is most likely an issue, and it is, we see it. But we don't balance it to see how different models work with heavily unbalanced datasets. Even doing data augmentation, there is so much difference that it increases a bit, but is not enough. So basic techniques of data balancing are improving the performance, but not drastically. So there is room for more research about it. Watson has the limitation of 20,000 tickets, so we downsample also to 20,000 for a fair comparison, even if it's, I mean, in the real business, then you use all your training set, of course. And we test on almost 5,000 tickets, because it was 10%, a bit more than 20% original training set. As I mentioned, we don't do label balancing. Do it when you when you have your project, of course, because it's extremely important. Data were already pre-processed, so we couldn't evaluate the impact of different pre-processing. I assume that is extremely relevant for the LGBM and for fast text that learn from scratch and with relatively small amount of data. I'm not sure about how much it impacts with transfer learning, because the model is pretty robust already, so I don't think it will get much affected, but I'm just assuming it. We didn't check it. And then we remove special characters and replace each number with 0.
Oh, sorry.
Yes.
I have a question about that. Replace each number with 0. I've never seen that actually. Can you elaborate?
Yeah, this is just due to the domain that is very specific. So several tickets contain IP addresses and machine numbers, but this doesn't really matter for the ticket type.
Right.
So you just help the model to
Okay,
learn that
so
all numbers, all the IPs are the same. Otherwise, they would get represented in different ways.
Cool.
So you reduce from some thousands of different numbers to one.
Mm.
This is what tickets look like, and we merge the title of the ticket and the body. Sometimes it's even difficult to understand exactly what they were asking, but yeah, this is what is available online. So I didn't understand the first one, but I wanted to show it to you as well. So just point out that it's not always so easy to understand what people want to get. We evaluate it with the F1 score. That is just a good metric. I don't think it's the only thing you should focus on, but it's a good representation to quickly see how models perform, and they just combine precision and recall. I guess you all know what it is, but the first one says how many selected items are relevant out of all the selected items, and the recall says how many relevant items are selected out of all the relevant items. One can decide to maximize for the recall or for the precision depending on the business case, but in general the F1 is a good metric. And we then arrive to the comparison of the performance. Before going, any other question?
I have a question about the pre-processing. Did you use TF-IDF for all of these methods? Like for all of, like for comparison? I mean, there was that.
No.
Okay.
We use it for a GBM
All right, I see.
because all the others want text as input.
I see.
How many different words were included in the vocabulary for TF-IDF? You know.
10,000? But I'm going by my, I'm quite sure, but not 100%. But I think 10,000. That were basically all the words appearing in the end. So. Yes. Okay. Let's go straight to the F1 results. Darker the green, the highest the value, and it seems that Google models are outperforming the others. However, I don't think that is the only thing one should look into, and I will mention some reasons now. The baseline is 59%. That is just by predicting the majority class. Very, very bad baseline. But if your model gets worse than that, you can just go for it. For some business, 60% would be good enough. You have always to think about what you are working with, and I know that developers like to get the cool tech things working. Companies want the business, so we need to find a good balance with it. GBM and IBM seems to be the worst performing. However, I want to point out that there is maximum 2% difference between the models, so it's not. It might be extremely important. It might be not relevant at all, and one can just focus on price or speed or other features.
Was it important in your case?
In our case,
2%.
2% is relevant in some labels, is not relevant in all labels. Because now we consider all that we have 12 labels, so 12 classes that we classify into. And in the evaluation of the F-score and when you look at the results, they all get the same importance, or they are weighted depending on how many items appear per label. But behind them, there might be the financial tickets, the IT tickets, the critical tickets of the server going down and the website being offline. So one should really focus on each label and see the performance. So 2% can be a lot and can be nothing. For us, it's not extremely relevant. No. The inference time, fast text is the fastest. Makes sense. It was developed also for that. BERT was quite fast in the inference. I didn't compare the training time because it's not live training, so it doesn't really matter if it takes half an hour or half a day. The inference time of BERT is a bit cheating because it was running on a GPU and the others were not. But in general, for the use case, it doesn't really matter because if a ticket gets classified in 3 milliseconds or in 1 second, it doesn't change for the business. AWS was running using their user interface, and I think that if you use the REST API or the client library, it's much faster than the inference. I don't see why it should take 5 minutes to classify 1 sentence. For the GVM, we didn't use the GPU support because it's quite tricky to implement, and it was quite fast, so we didn't see point.
Why is there such a big jump between classify 1 ticket and 4,800 tickets?
Because
all of them except fast text and LGPM. They all jump quite significantly.
Okay.
And AWS actually doesn't jump either.
AWS doesn't jump, and I don't understand why. But I assume it's some delay in the network when reaching the machine, and then it takes like 2 seconds to classify all of them. So that's the difference, and it's quick at doing the actual classification, but it's slow at transferring data. Probably they down prioritize users on the user interface. I'm not sure. And in Google Cloud is because every time you have to call your model, sending one document, classifying it, and getting back the result. So basically it scales linearly with a number of tickets.
Yeah.
While GBM fast text, you just put everything together. In BERT, you put one batch per time, so it's like 32 sentences classified per time.
Okay.
I mentioned also the model size on disk. I couldn't monitor the RAM usage because I was doing other things in parallel, and it was quite complex. But I mentioned fast text is quite large, and this may be not a problem, but it has to be considered if you have to deploy 200 models, because maybe you have a lot of categories, subcategories that you want to have one model specifically trained for each one, and you have to consider the model size. BERT is not so small. This is the dimension of the checkpoint that you save. So as I mentioned, we fine-tune the classifier and the top layer, and we save the new weights. But the overall model was 420 megabytes. But if you have several models, you keep just one pre-trained model in memory, and then you load the checkpoint, depending on your need. Sorry if I'm running a bit, but we started a bit late, and I would like not to finish too late. I mentioned that the F1 is not the only thing one should focus on. We evaluate how the performance change if we discard low confidence score results and predictions. So you should always find a balance between the automation and the performance that you get when applying AI to a solution. And we can see that FastText and AWS are really confident when they give a prediction. So either you discard everything or nothing, basically, while the others allow you to play with this parameter and decide how to optimally develop your solution. BERT is unconfident, even if it's good. So, of course, you have to check what is the optimal point for your case. More interesting is how much the F1 improves when we discard some results. I think it's interesting to observe the pattern difference between the GBM and IBM results, because if you look at the F1 was the same, but it seems that the GBM is really good at giving high confidence when the result is correct and low confidence when the result is wrong. So by discarding some results, we improve drastically the performance. While I guess that IBM Watson doesn't do it so well, so it's sometimes overconfident on wrong things, and it doesn't have high confidence score when it's right. So one has to decide where to stay. Is it fine to discard 10% of your results and stay above 90% F1? Yes, no, take your choice. Here is how the distribution of labels between the predicted labels and the true labels look like. There are quite similar patterns, and it seems that FastText and AWS have quite similar model because they answer in the same way, they are good on the same classes, and now it's a bit difficult to see it with projected. In the PowerPoint it was a bit easier to see the overlapping ones. I'm sorry, I didn't expect it. Didn't try it on this screen. But more interesting, I think, is the percentage of errors per each label. And this is clearly showing that you need more data per each label because models cannot learn with a few samples. The cloud services suggest to use at least 100 samples per label. Some classes are basically never classified correctly, but this might not be a problem. So you could find that, for example, all tickets labeled as number 1 end up in class number 3, and this might not be a problem at all for your business because it's the same group. Or you can decide that some results are not acceptable. So if it's predicted label number 3, don't do anything that asks the user. So you can get improvement in your business even if the automation is not complete in the beginning. Gather more data, retrain the model, and keep the loop ongoing. I just show some conclusions that I draw. I would like to hear something from you as well. Remember that there are not only technical issues, but security and privacy are important as well, so this has to be considered. If you have really large amount of models that you have to store in a small business, IBM gets expensive because they charge $20 per month per model. So if you have thousands of models, it starts getting expensive. And about the confidence score that I think is really showing how good a model is learning, and it helps us playing around with the threshold. AWS and FastText are almost always sure about their predictions, while the other models are smoother, even if all of them are most of the time sure about what they're outputting. BERT is almost never. I don't know if this is a particular implementation that is reducing the maximum confidence that it gives out, or if it's in its nature of distributing more the confidence score across different classes. Consider that increasing the threshold doesn't always mean improving the performance. We can observe, for example, that here, if we discard the results with less than 60% confidence score, we get much more errors in some labels. The majority class gets better, so of course it's the class that it learned better to represent. That leads to a general increase in the F1 score, but it might not be optimal for your use case if label number 6 is business critical, for example. Anyways, having very high confidence score in all predictions prevents you from being flexible, and as I mentioned, you should always find a good balance between automation and results. So, in my opinion, there is not a clear winner. Thorsten, for example, mentioned that FastText is really good, and it is, but it has the limitation of the high confidence score that blocks you from moving the threshold. So you should consider your business requirements and go into the results deep and spend a lot of time on looking at the actual data and see where labels end up Y, and see what you really need to be extremely accurate on and what is fine to just be so and so or not automatized at all. You should consider expertise availability, because of course that might not be the case for all companies, and in that case you can just go for some cloud services that are very well performing and don't require any specific machine learning knowledge. Budget. Cloud services are expensive, engineers are as well, so I mean, it depends on what you need. Consider security and privacy limitations and the automation and performance trade-off. That should always be considered. As I mentioned before, all these points are relevant in any AI case and machine learning project, so you can just hopefully remember some of these points, try to think about in next projects. And for me, it's all. If you have any questions, please feel free to ask.
Can you show the slide on the training accuracies? Was it training accuracy, I think? Because isn't it strange that all these AutoML platforms are performing as well as the transfer learning models you're running locally? Maybe I'm getting it wrong.
No, I don't think it's, well, Google Cloud, I don't think it's strange because they probably use the same model in the backend.
Okay, so it's not really AutoML in that sense, based on the result.
I'm not sure, but if you look at the patterns, they are really similar.
Yeah.
Both in this case, either if you look here,
Insanely similar.
yes. So I'm quite sure that they have just some different transformers behind it and they try them. So
Alright.
they do some parameter fine-tuning, hyper-optimization, but they don't do much more than that. I don't think they build the network based on your data. Maybe they have different pre-trained models that they have pre-fine-tuned, and they try to identify which topic is your data about, and then use that model. I'm not sure, but I guess they do something like that.
So the gain is not that much, considering that.
Well, because they released BERT.
Yeah.
So if you had to do it by your, but no, it's not much actually. At least in this use case, it's not much because we can see that fast text is quite similar, or the GBM is quite similar. So one could use the GBM by discarding 15% of the results and getting 91 F1. Have it running on a CPU instead of 12 GPUs in parallel. Yeah.
I just wonder if you want something quick, just to test some stuff, which of them is easiest to get started with?
If you know programming or if you
If
don't.
you know programming.
Fasttext is really easy to use if you know Python.
Yeah, probably fast text.
Okay.
But no, the easiest thing is just to pick your data and put them in S3 and create the AWS
Okay.
comprehend service. But
AWS comprehend. Okay.
AWS has very good documentation and nice graphical interface, so it's easy to use, at least in the machine learning component. Google is more developer oriented, and it doesn't, or now it has a graphical interface, but not easy to use. Yeah. But also the GBM I want to mention. If you use scikit-learn and then the GBM libraries, they're quite easy to get started with.
So, since you compare models are very recent and models are a bit more aged, do you think the next step in performance increase is going to come from new models, new architectures, or is it just going to come from having more and better data than just this repository that you focus on?
From data. From data, because of two main reasons. You will always have heavy unbalancing in this type of problem, because in nature, many more tickets are raised in one category rather than another. And there is another additional problem that I didn't mention before, that is that a lot of tickets are wrongly classified in the dataset because users set the wrong class in the beginning. So the massive work is required to clean the tickets using some IT support expert and check the quality of your data. That bad results are probably, or these misclassified tickets are probably setting a limit that you can achieve in performance because you're teaching the wrong thing and you cannot find a pattern that doesn't exist. So, but I personally believe in data augmentation as the next big breakthrough in natural language processing, and I just mentioned we will have a thesis next semester on data augmentation in natural language processing. They will be published soon in the Stockholm AI page on KTH. But in general, I think that it will be the next big step in NLP.
For the class imbalance problem, do you have any solution architecture-wise or just the more data?
Can you repeat the question?
For the class imbalance problem, I mean high imbalance in different classes, do you have any solution architecture-wise, I mean, or just more data is the only solution for now?
I guess it's more data, but there might be some architectures that work better than others. What one can consider is going away from the technical side and consider the business. We have 12 classes, but there might be 3 resolution groups. So you can merge maybe 3 or 4 labels together, then do some data augmentation on those, and then you have 3 classes classification problem, and it's much better than having 12 classes for sure. So yeah, data augmentation and considering what actually the data are and not just the number behind it.
Any more questions?
Are you satisfied?
So I was just wondering, like a Swedish, Norwegian, Danish, how is it going to work with like lemmatization and then maybe these algorithms?
I don't speak Swedish, so I can read something. No, I know that they will release a Swedish version next year with some research institutes and companies. And the point is that with transformers, you are less dependent on the performance of the lemmatization and stop-words removal because you get advantage of the large data set. So the model itself probably learns that they are not important. Lemmatization and stop-words removal have a huge impact when you consider the word frequency, like in TF-IDF, or when you train a model on small amount of data. So I haven't seen Swedish models for embeddings, but I guess there are.
Did you consider evaluating laser? Laser is, I don't think it's as good as BERT, but it's language agnostic. So it works very well for Swedish.
No, not yet. But also, basically, also FastText, for example, is language agnostic because you just use your training set and it doesn't know if it's English, Swedish, or any kind of, even TF-IDF and the GBM just counts the frequency and then train a tree. But I will look into it. Thanks.
But none of the models was pre-trained anyways, apart from BERT. So
Yes.
it shouldn't really matter what language you use.
Yeah, exactly.
Cool. Thank you for an excellent talk, Emilio. I have a final question. Are you at Seavus deploying a service management solution to some customer?
We are testing it now. We will start using it internally to find where it works good, what we need to do better, because it's a critical part of the business. So we want to first try it on ourselves. But we are speaking with some customers. I cannot say more about, but we are speaking with some customers.
Thank you.
One more question.
One more question.
What's the cost of a misclassified ticket? So in terms of money, I mean, if you get
Ton is not here, but there are estimations of some billions of dollars per year worldwide. I read research from, I don't remember which consultancy firm, that was stating $70 per password request, and not misclassified, just for a password request, password that is actually blocking the user from using the system. It's quite impressive. I feel, like, my feeling is too much, but they know it better than me, or they did market research. It's billions of dollars per year, for sure. I was speaking with a colleague that they were working in a big American corporation. They had 2,000 IT support teams, and they had a ticket of someone working and having problems with a software that was handling hundreds of millions of dollars that remained blocked for 1 week. So you can, it's probably tens of billions of dollars per year. But I don't want to think too much. I have to make it work in the
So now we have a break for 20 minutes, and you just can go around and socialize, and then after that Fredrik is going to talk more. Thank you.
Thank you.
Thank you, everyone.